welcome to Erudite Education. We drive to seek knowledge. In the last lesson, we actually discussed about how the divisibility tests from numbers of 2 to 10 work, and I had promised you guys that in the next lesson we would be continuing off with the topic of divisibility test. So in this particular lesson, what we are going to study in detail is about how exactly the divisibility test from the numbers of 11 to 20 work. Now, GRE is an exam which has some level, so for that level I think 11 to 20 are the most important numbers for which you guys should know the divisibility tests. They are very simple. Once you keep them in mind, you will understand them very easily. So we are going to discuss them right now. But before we start, don't forget to like, share and subscribe to my channel so that you guys would be updated with the upcoming lessons every week. So as I said, the topic that we are going to start today is the topic 2 from the chapter of divisibility test from the integers part, and this is the second part of the chapter wherein we are going to discuss the divisibility tests from numbers of 11 to 20 in the ultimate GRE guide for quantitative reasoning. So the first number obviously we are going to start with is 11. So let us discuss the divisibility of 11. Now for the divisibility of 11, you first need to calculate the sum of the alternate digits, and you will get two sums because you're taking alternate digits, so obviously there will be sum 1 and sum 2. The difference of sum 1 and sum 2 should be divisible by 11. Let's make it clear with the help of an example. So I am taking some number over here. I am taking a number which is 11977,658. So first of all, let me underline the alternate digits. Now make sure that whenever you are counting the alternate digits, it should always be from left to right. So my first set of alternate digits will be 1, 9, then I'll have the 7 and 6 and 5. So my sum will consist of these 5 digits. So I'll have 1 plus 9 plus 7 plus 6 plus 8, which will give me a sum of 31. Now let us take the remaining alternate digits and find out their sum. So I have the remaining digits as 1, 7, 7 and 5. So the remaining alternate digits will have a sum of 1 plus 7 plus 7 plus 5, which comes out to be 20. If you calculate the difference of the sum, you will find that the difference comes out to be 31 minus 20, which is 11. Now 11 is actually divisible by 11, so I can say my entire this 8 digit number is completely divisible by 11. Isn't it simple? You just need to calculate the sum of the alternate digits and then take the difference. Let's clear it with one more example. The second example is a 5-digit number 25784. So taking the alternate digits from left to right, I have the first set as 2 plus 7 plus 4. Now this comes out to be 9 plus 4, which is equal to 13. And my second set would be 5 plus 8, which is also equal to 13. So my difference of the sum of these two becomes 13 minus 13, which is equal to 0. Now because it is 0, you won't say that the number is not divisible by 11. 0 is divisible by any number. So I can say that my 0 is divisible by 11. So my 25784 is also divisible by 11. So that is how the simple of divisibility test of 11. For divisibility by 12, as I said, for any number which can be expressed as a product of two prime numbers, you just need to see that the number is divisible by those two prime numbers. So 12, I can express it as a product of 3 and 4. It is not compulsory that both of the numbers should be prime numbers. What is necessary is they should be co-primes, that is, they should not have any common factor. Over here you can see that my 3 and 4 do not have any common factor. So I can say that for my 12, what I need to do is I need to find out if my number is completely divisible by 3 and 4. So for 3 we know that the sum of the digits has to be divisible by 3, and for 4 we know that the last two digits should be divisible by 4. So I have taken a number over here which is 1440. Now if we calculate the sum of the digits of 1440, it comes out to be 1 plus 4 plus 4 plus 0, which is 9. 9 is a number that is divisible by 3, so 1440 is divisible by 3. Then I have another number, then I have 40 as the last two digits. 40 is divisible by 4, so my number is also divisible by 4. So I can say that my entire number is divisible by 3 and 4, so it is divisible by 12. So whenever you have a number that can be expressed as a product of two co-prime numbers, co-prime as in they should not have any factor in common other than 1, then those two co-prime numbers, their divisibility if the number is divisible by those two co-prime numbers, then your number would be divisible by that particular number. Like for example, over here we had 12, so it can be expressed as 3 into 4. 3 and 4 both are co-prime to each other, so I can say that if my number is divisible by both 3 as well as 4, then my number is definitely going to be divisible by 12. The next is divisibility test of 13. Now this is a little tedious one, but this is very useful when you have very large numbers like I have taken in an example over here. So you need to form the alternating 3-digit blocks from right to left, and you need to add 4 into last digit to the remaining number and subtract the last 2 digits from 4 into remaining number, and then subtract the 9 times the last digit from the rest. I know these steps are a little complicated to remember, but if you remember them, then you can easily find out if your number is divisible by 13. So the first step says form alternating 3-digit blocks from right to left. So as we were taking alternate digits, over here we need to take alternate 3-digit blocks. So my first 3-digit block would be 587, the next one would be 461, and the last one I have only 1 digit remaining, so I'll consider only 1 digit. The next step says add 4 into the last digit to the remaining number. So what I'm going to do is I'm going to add 4 into the last digit to the remaining number, but uske pehle we need to find out the difference of these. So what I'll do is 4 minus 461 plus 587, which comes out to be 130. Abhi is 130 ka 4 into last digit you need to add to the remaining number. Just make a note that after this first step, before the second step, you need to find first the alternating sum. That means एक बार प्लस लेना है, एक बार माइनस लेना है. You have to start from subtraction. So 4 minus 461 plus 587, you get 130. Now for the number 130, you have to take 4 into the last digit and add it to the remaining number. So my last digit over here is 0. So 4 into 0 to the remaining number. The remaining number after 0 is cancelled, remains 13. So 4 into 0 plus 13, which comes out to be 13. It again says subtract the last 2 digits from 4 into the remaining number. So 4 into the remaining number is 4 into 0, you can see, and I have to subtract the last 2 digits from 4 into the remaining number, so it comes as minus 13. Then it says subtract the last 9 times the last digit from the rest. So my last digit, it is actually 13. Now over here we did not have subtract the last 2 digits from 4 into the remaining number. Now remaining number over here was 0 because we got a 2-digit number after the second step. So I'll take the remaining number as 0 and my last 2 digit is 13. So I'll subtract 4 into 0 minus 13, which gives me minus 13. After that I need to subtract 9 times the last digit from the rest. My last digit over here is 3. So 3 into 9 is 27. So I need to subtract 27 from 1. Don't consider the negative sign. So 1 minus 27, it comes out to be minus 26. My minus 26 is divisible by 13. So I can say that my entire number is divisible by 13. Let's repeat the steps once again. I have a particular number. First of all, I need to form the alternating blocks of 3 digits. Start from right and go towards the left. So I have taken coupled 3 digits. 587 is my first set. Then I have 461, and at the end I have 4 that is remaining. So keep it as it is. Now what you need to do is add and subtract, then alternately start with subtraction. So what I'll do, 4 minus 461 plus 587, which gives me 130. After this is done, what I do, I add 4 times the last digit to the remaining number. Now the last digit over here is 0, so I'll add 4 into 0 to 13, so it comes out to be 13. Now मेरे पास number जो बचा है, that is 13. I need to take the last 2 digits and subtract it from 9 times and subtract it from 4 times the remaining number. So the remaining number, if I take the last 2 digits, is actually 0, so I'll subtract 13 from 0. So 0 minus 13 will give me minus 13. After this step, I need to subtract the 9 times last digit from the rest. So the last digit is 3. 9 into 3 will give me 27. The rest of the number is actually 1. So 1 minus 27 gives me minus 26. Minus 26 is divisible by 13. So I can say that my entire number is divisible by 13. When you write these 4 steps, make sure that you add one more step over here wherein you are grouping this and you are adding and subtracting them alternatively. I know the test of 13 is a little complicated. You can remember it, or either you can carry yourself in the paper as you want. Now for divisible by 14, again 14 can be expressed as the product of 2 co-prime numbers 2 and 7. So for my number to be divisible by 14, it has to be divisible by 2 and 7 as well. For divisibility by 2, we already discussed the number has to be an even number. From 7, what you need to do, take 2 times the last digit and subtract it from the rest. So I've taken a 4-digit number 4746. Since it is an even number, obviously it is going to be divisible by 2. For divisibility by 7, I'll take 2 times the last digit, that is 6 into 2, which is 12, and subtract it from the rest of the number. So I'll subtract 12 from 474, which gives me a result of 462. Now 462 is divisible by 7, so I can say my entire set is divisible by 14. That was it for the divisibility of 14. For divisibility of 15, again 15 you can express as a product of two co-prime numbers 3 and 5. So you need to say if the 15 is actually divisible by both 3 and 5. For divisibility test of 3, we know that we need to take the sum of the digits, and for divisibility by 5, we know that it should either be 0 or 5 in the units place. So I've taken a very simple example, 750. If you take the sum of the digit, it comes as 7 plus 5, which is actually equal to 12. So 12 is divisible by 3, so 750 is completely divisible by 3. Then for divisibility by 5, I'll check the digits at the units place. It is 0. So obviously my number is also divisible by 5. So since my number is divisible by both 3 and 5, my 750 is divisible by 5. Next is divisibility by 16. For divisibility by, if you remember, for divisibility by 2, we used to check the last digit and we used to check if it is even and divisible by 2. For the divisibility by 4, we used to check if the last two digits are divisible by 4. For divisibility by 8, you used to check if the last 3 digits are divisible by 8. So you can see a pattern over here. If I have 4, I am checking if 2 raised to 2. That means the power of the 2 is actually divisible by 2 or 4 or not. For 2 raised to 3. So for any 2 raised to n divisor, I will check if the last n digits is divisible by 2 raised to n. So I can express 16 as 2 raised to 4. So what I am going to check if the last 4 digits are actually divisible by 2 raised to 4. Check the last 4 digits over here, 5936. If you see 5936 is actually divisible by 16. So my number is divisible by 16. So for any number that can be expressed in the power of 2 raised to something, I have to check the last n digits and check if the last n digits are divisible by 2 raised to n or not. If they are divisible, then test is satisfied. Now for divisibility by 17, again it is something similar to the divisibility by 13, very difficult, but I hope you guys will remember. But this has a particular pattern, so divisibility of 17 is actually a little easy to remember. So I am not giving you any particular steps. So what you need to do in every step is you need to take the last digit and multiply it. So for example, I am multiply it by 5. I am taking an example of 43146. Over here my last digit is 6. So what I'll do, I'll multiply 6 by 5 and subtract it from the remaining number. So 6 into 5 is 30. I'll subtract 30 from the remaining number, which is 4314. 4314 minus 30 gives me 4284. Now consider 4284. Take the last digit, multiply it by 5 and subtract it from the rest of the number. So I have 428 minus 4 into 5. So it gives me 408. Take 408. Extract the last digit, multiply it by 5 and subtract it from rest of the number. So my last digit is 8. So 40 minus 8 into 5, which gives me 0. 0 is divisible by 17. So I can say that my 5-digit number is divisible by 17. So you can observe a pattern over here. You have to extract the last digit, multiply it by 5 and subtract it from the remaining number until you get a number that you know is actually divisible by 17. Taking one more example. I have 5627, extract the last digit, it is 7. So 562 minus 7 into 5, which will give me 527. 527 ka last digit le lo, it comes out to be 7. So 52 minus 7 into 5, which is 17. Now 17 is divisible by 17, so I can say that 5627 is also divisible by 7. So that was all about divisibility test of 17. For 18, I can again express 18 as a product of two co-prime numbers 2 and 9. So if my number is divisible by both 2 and 9, I can say that it is divisible by 18. For divisibility test of 2, it has to be an even number, and for divisibility test of 9, the sum of the digits has to be divisible by 9. If I consider 17334, it is an even number, so I can say my number is divisible by 2. Again, I can see that the sum of the digits is 1 plus 7 plus 3 plus 3 plus 4, which comes out to be 18. 18 is obviously divisible by 9, so 17334 is also divisible by 9. So since it is divisible by both 2 and 9, I can add my divisible by 18. The next one I am taking is divisibility by 19. Now even this actually follows a particular pattern. What you have to do is, just as in divisibility test of 17 you are multiplying the last digit by 5, over here you need to extract the last digit, multiply it by 2 and add to the rest of the number. Over there you were subtracting, over here you are going to add. So let's take an example. 6935, extract the last digit, it is 5, the remaining number is 693. So it becomes 693 plus 2 into 5, which gives me 703. Take 703, extract the last digit, it is 3. So 70 plus 2 into 3, which will give me 76. So 76 is divisible by 19. So my 4-digit number is divisible by 19. A very easy pattern. Extract the last digit, multiply it by 2 and add it to the rest of the number until you get a number that is actually divisible by 19. Let's take one more example. A 5-digit number, 69445. Take the last digit, multiply it by 2 and add it to the rest of the number. So 6944 plus 2 into 5, which gives me 6954. Now take 6954, extract the last digit, which is 4. So 695 plus 2 into 4, which will give me 703. Take 703, 70 plus 2 into 3, 76 is divisible by 19. So my entire 5-digit number is divisible by 19. So that is how you need to determine the divisibility test. Very easy. Again, divisibility test by 20. As I said, it can be expressed as a product of two co-prime numbers 4 and 5. So I need to see if any number is divisible by 4 as well as 5 to check the divisibility of 20. So for example, I am taking 15,6900. You can see the last digit is 0, so obviously it is divisible by 5. Again, the last two digits are 0, 0, so it is divisible by 4 as well. So I can say my number is divisible by 20. So that is all about the divisibility test from 11 to 20. There are some simple ones. The most complicated one is the divisibility test of 13. It is good if you guys can remember it, but I don't think it is going to help you in the exam because the time that is taking for doing the steps is actually a very long time. So instead you can prefer going for the actual division. But for 17 and 19, I think they are very good methods and you should remember those methods. Even for divisibility test of 11, the one we discussed is the one that will be quickest. For again 12, you have to see 3 into 4. For 14, you have to see 2 into 7. And for 16, you have to see 2 raised to n. For 20, you have to see 4 into 5. For 18, you have to see 2 and 9. So I think it is quite simple. Whenever you have a number that you can express as a product of two co-prime numbers, check if the number is divisible by each of the co-prime number. If it is, then yes, it satisfies the divisibility test. Again, if you have a number that can be expressed as 2 raised to n, then check if the last n digits of the number are divisible by 2 raised to n. In such a case, you will find that the number divisibility test would be satisfied. And for 17 and 19 is only the stuff that you need to remember. So that was it for this particular lesson. I hope you guys are benefited because I have taken the tests which are actually very quick and it will help you to save time in the GRE examination. So make sure you make a note of these tests. And in the next lesson, we'll be continuing off with the fractions and the decimal part from the part of integers. So that's for the lesson. I hope you guys have understood all the topics. If you have not, if you have any doubts, you can leave them in the comment section below. Thank you so much for watching, and also don't forget to hit the subscribe button. Do like, share and subscribe to my channel and stay updated to all of the upcoming courses. I'm sure that it will definitely help you guys. Thank you so much for watching. Have a great day.